Hello everyone. In this question, it is asked that if S equal to A plus B plus C plus D, where A, comma B, comma C, comma D are positive unequal numbers, then we have to prove that the product S minus A times S minus B times S minus C times S minus D is greater than 81 times ABCD. Okay, so let us start. We are given that S is equal to A plus B plus C plus D, and we're given that A not equal to B, not equal to C, not equal to D, and all of these are positive real numbers. Okay, so if we try to find the value of S minus A, this will be equal to, from this equation, it is equal to B plus C plus D, right? Similarly, S minus B will be equal to A plus C plus D, and S minus C will be A plus B plus D, and lastly S minus D will be equal to A plus B plus C. Okay, so these are the four terms in the product in the left hand side of the proof. Okay, so we have to get this 81 times ABCD. So if I try to manipulate this these terms in the RHS of this S minus A, S minus B, S minus C, and S minus D, and try to see if we can use some inequalities. Okay, so since these are positive real numbers which are unequal, the arithmetic mean for this, since let's say I take this first number, okay, BCD, since BCD are all greater than 0 and these are not equal to each other, okay, therefore the arithmetic mean of BCD will be strictly greater than the geometric mean of BCD. Okay, the equality of this relation holds if the numbers are equal to each other. Okay, since these are unequal and positive, the arithmetic mean is strictly greater than the geometric mean. So this will imply that B plus C plus D upon 3 will be greater than the cube root of the product BCD, right? So if I take B plus C plus D in the left hand side and cross multiply the 3 to the other side, this will imply that this is B plus C plus D is greater than 3 times the cube root of BCD. Okay, so this is B plus C plus D, right? Now B plus C plus D is nothing but S minus A. So this implies that S minus A will be greater than 3 times the cube root of BCD. So similarly, I can use this for the other pairs also, right? I can use this relation that AM greater than GM for the other pairs also, for the pairs ACD, ABD, and ABC. Okay, so similarly, we get S minus B will be greater than 3 times the cube root of, see, in the first case it was S minus A, right? And in the cube root A was missing. So similarly, since it is S minus B here, the cube root, the term inside the cube root will be A, C, and D. And similarly for S minus C, it will be greater than 3 times the cube root of A, B, and D. And for the last case, S minus D will be greater than 3 times the cube root of ABC. Okay, so it seems that if we multiply these four cases together, if we multiply these together, it seems like it is matching the structure, right? So let's see what happens. Now S minus A times S minus B times S minus C times S minus D, this will be greater than, since each of these inequalities are greater than the left hand term is greater than the right hand term. If we multiply this, the inequality will still hold, right? So this implies this will be, there are there are 4 threes, right? So it is 3 to the power 4 times cube root of, first term will be BCD times ACD times ABD times ABC, right? So now we get S minus A times S minus B times S minus C times S minus D. This will be greater than this 3 to the power 4 is nothing but 81, right? 81 times cube root of, if I open the bracket here, there is 1A times 1A times 1A. So this is A cube, right? A cube times 1b, here 1b and here 1b, b cube, c here, and in the c in the last term, c cube. And similarly, d is in the first three terms. Okay, so this is a cube, b cube, c cube, d cube. So we are almost finished here. S minus c times s minus d. This is greater than 81 times. This is nothing but cube root of a b c d whole cube, right? I can rewrite this as like this, right? A cube, b cube, c cube, d cube as a b c d whole cube. So this cube and this cube root will cancel out. So finally, we now have s minus a times s minus b times s minus c times s minus d. The product is greater than 81 times a b c d, right? So we have proved it. Okay, so this is it. Basically, I have just used the arithmetic mean and geometric mean for this s minus a, s minus b, s minus c, s minus d in terms of the remaining terms. Okay, and then from there I have just used their product. Okay, so this is it. Thank you.